So now I'm going to talk about when you need to use parametric tests. So you have to understand what the point of parametric tests is and to know when to use them. So first I'm going to start with a simple flowchart. So if the data is categorical, then you cannot use a parametric test. You have to use chi-square, binomial or Fisher's exact tests. Now if your data is not categorical, then the next thing you need to check is if the data is normally distributed. If it is, then you're going to use parametric tests, which are paired t-tests, unpaired t-tests, and ANOVA. Now parametric tests are the easiest type of test to understand and the most powerful. They're related to the ideas of confidence intervals, and there are two main tests which are for large and small samples if your data is normally distributed, called z-tests and t-tests. In reality, we're only ever going to do t-tests because those are the ones implemented in software. The hypothesis is your samples come from the same population. So if they come from the same population, the two different samples would have the same mean. Because of variation between samples, you're going to have a bit of a variation between mean. But is the variation between means so large that you don't expect that they can come from the same population? That's the basic idea, and that's the thing you're going to do. It relies on normally distributed data. You're going to do tests about the mean and the variance. If you've got a large population, then technically you can do a z-test. Small population, you do a t-test. In effect, you do it always as a t-test. And if you have multiple groups, so more than two groups, if you have three or more, then you have to use first an f-test to say if there's a difference between the groups, and then you do t-tests after that. That's a process called ANOVA, analysis of variance. So the test statistic is something that measures how much you agree with the null hypothesis. So in the chi-squared you have the test value, which is summing all the ranks, the differences that you get between what you expected and what you actually observed. For tests about the mean, what you want to see is how different are the means to one another between the two different samples. Is the average difference between the other different to 0? So if I've got a treated and untreated group, if the treatment's not working, then I get no change in the average things that I measure. Now, because of errors, data is never perfect and there's always the variation. So you have to determine what's noise and what is genuine variation. Noise can be intrinsic, so within the thing that you study, so humans have a lot of variability, or it can be external, so you've added it because of the way that you did your measurements. For example, about measuring height, you just measure to the nearest centimetre or the nearest inch, depending on what measuring scale you're using. So you have to think about, has your measurement increased and made the variation worse? So you need well-designed experiments to be able to test out your hypotheses. And then you can create a decision where you say, if the difference is bigger than this value, then I will reject my null hypothesis.